Today we build a home automation system with an ESP32 and a Windows PC. The system will have this cool user interface running in a browser on any PC or phone connected to the same Wi-Fi. So you will be able to read sensor data or control outputs of all ESP devices connected from a web browser. We will build up the system step by step and verify the function after each step. We first set up Node-Red on a Windows PC. Node-Red makes it really easy to build a user interface. There's no need for any programming. Node-Red is drag and drop and it automatically includes a server. On the same PC we install the Mosquitto MQTT Server. This will handle all the communication in the system on the background. Then we will set up the ESP32 in the Arduino IDE and program it with a basic sketch to connect it to the home automation system. Finally, we will power up the system and see how it works. This is an overview of the home automation system we will build. In the middle you see the Windows PC running Node-Red and the MQTT server. And on the right you see an ESP32 with an LED and a potentiometer. We can control the LED and read the potentiometer voltage from any browser in the Wi-Fi network. After you finish the project, you will have a home automation platform to which you can add as many ESP devices and sensors as you wish. So you will need a Windows PC, an ESP32 development board and a potentiometer to do this project. The LED is optional because we use the built-in LED. So let's get started. We start with installing Node-Red. Go to nodred.org, then scroll down to Run Locally and click Getting Started. Click on Running Locally again and select here the Windows option. Now we first need to install Node.js. So open this link and download Node.js. This will install the Node.js Java runtime environment and the npm installer you will need to install and use Node-Red. When the download is complete, double-click the MSI file and follow the instructions. You do not need to install the additional tools. Click Finish and you're done. Now we go back to the Node-Red website and install Node-Red. For that we open a command prompt and execute the command they mention here on the website. Copy, paste and press enter. This will install Node-Red. It may take some time. And you're done. To start Node-Red, open a command prompt and type node-red. Enter. Now Node-Red has started. Now minimize this window. Do not close it because then you will stop Node-Red. And open a second command prompt and check your IP address with ipconfig. Here you see the IPv address. It's 192.168.164. Copy this address, open a browser, paste the IP address and add a double dot 1880, enter. And here you see the Node-Red development environment. Now we need to add a set of nodes for switches and gauges. Here go to Manage Palette and go to the Install tab. Click on Refresh and search for Node-Red-Dashboard. Here you see Node-Red Dashboard, click on Install. So the dashboard has been installed, we can close this and we can start making our user interface. Let me first show you how to import and export nodes. You can find the example flow in the zip file linked in the description. Go to this text file, then select all with Ctrl A, then copy with Ctrl C, then you go back to Node-Red and go to import and paste the text in this box. Then click on import. And now all the nodes are imported and your flow is ready to use. Click on deploy. Now to export these nodes, you can select them by dragging a box. Click on export, copy to clipboard, and you can paste this information then in a new text file. And here you have your flows. And this way you can save your flow. Now I will delete these nodes and show you how to create your own. We go down and here you see the dashboard nodes. What we will need is a switch, a gauge and a chart. Then to read the MQTT messages and send MQTT messages, we need an MQTT in and an MQTT out. The switch will be connected to the MQTT out. You just drag a line here. And the MQTT in will go to the chart and to the gauge. Now we are going to configure the individual nodes. First the switch. We need to add a new dashboard group because we don't have one yet. Just keep it default. And we say add. Done. For the gauge, we only change the maximum range to 100. Done. The chart, we don't change anything and also press on done. We will not configure the MQTT nodes yet. Press deploy. Confirm. Now the dashboard is finished and you can see it by copying this IP address, opening a new tab, press paste and add behind the IP address and the port 1880 /UI for user interface and press enter. And here you see your user interface. The switch is working, the gauge does not have data yet, so it's at 0. So this is how easy it is to make a user interface with Node-Red. Now we are done with Node-Red and we continue with the next step, setting up the MQTT server. We will use the Mosquitto server. For this go to mosquitto.org, download the Windows installation file. When the download is complete, go to downloads and run the installer. The installation is complete. Now we go to C, Program Files, Mosquitto, and find mosquitto.conf. I suggest you first make a copy, paste, and now you open mosquitto.conf. Then you add one line, listener 1883. This defines the port is 1883. And then uncomment allow anonymous and write behind it true. Now save the file. Close. Now we need to open port 1883 in the Windows firewall, otherwise communication will be blocked. Go to search and type here wf.msc. Now we create a new inbound rule. New rule. It's a port. Next. And then type here port 1883. Next. Allow the connection. Next. And select all. Next. And we call it Mosquitto MQTT. Finish. So now the port 1883 is open for Mosquitto MQTT. You can close this. And now we open a command prompt. We can do that in the Mosquitto folder by typing here cmd. That's a cool trick. And type net start mosquitto. and your Mosquitto broker or Mosquitto server has started. Now let's start Node-Red and see if we can connect to the Mosquitto MQTT broker. Node-Red. The IP address is 192, it still remembers it, 168.164. Let's enter. Here we have an MQTT node. So we don't have a server yet. So we added this. Let's call this Mosquitto local server 192.168.1.64 and the port is 1883. Update. For the topic we choose ESP32/temperature. We will later use that in the C++ code for the ESP32. Done. Deploy. Confirm. And you see it is connected. Now we can also open this MQTT node and we select here this broker. The topic here will be ESP32/output. QoS we take 2, that's the highest quality for communication, and we press done. Deploy. So both are connected now to the MQTT broker. Let's build the ESP32 circuit. Please connect an LED and a potentiometer as in the schematic. I use an ESP32 room. If your ESP32 board is a little different, it will work fine. Just pay attention to the GPIO numbers. D34 for the potentiometer and D2 for the LED. Also make sure to connect the potentiometer to 3.3 volt and not to 5 volt because that may damage your ESP32. I use D34 for analog in because if you use Wi-Fi, only ADC1 is available. So you can only use the GPIOs shown here if you need Wi-Fi. Took me quite some time to figure that out. Now let's go to the Arduino IDE to set up the ESP32. I connected the ESP32 circuit and opened the Arduino IDE. We first add the ESP32 boards to the Arduino IDE. For this we go to File, Preferences, and we paste this URL in the Additional Boards Manager. I will leave this link in the description. Press OK. Now we go to Tools, Board, Boards Manager, and we search here for ESP32. Click on Install. This installation will take some time because all the packages together are a few hundred megabytes. So the installation is complete, and here are Tools, Board, so you see there are many boards available. Now we will install the USB drivers for the ESP32 boards. If you open your device manager, you see your ESP32 board. Open the search engine and search for Celap's CP210X driver. Click on this link. I will leave a link in the description. Go to Downloads and download the CP210X Universal Windows driver. Then open the Downloads folder and here you see the file. Double click, extract, OK. Then you go to your device manager, double click, driver, update driver, and browse the computer for drivers and go to the downloads folder. OK, next, and the drivers are installed. Now we go back to the Arduino IDE and we open the Blink example. Then we go to Tools and select the port, in my case it's COM10, and we go to Select Board, and here we search for DoIT ESP32 DevKit v1. Now we change LED built-in to 2, so we know for sure that it is digital output 2, and we compile the sketch. The IDE is blinking, so the ESP32 board is working. Now let's have a look at our home automation code. This is the ESP32 code. The Wi-Fi library is included in the ESP32 board, so you don't need to install that. The PubSubClient library is the library for the MQTT communication, so we'll need to add that. For this we go to Sketch, Include Library, Manage Libraries, and search here for PubSubClient, and it's this library, PubSubClient by Nick O'Leary. Install. So the library is installed. Then here you need to add your own Wi-Fi SSID name, and here the Wi-Fi password. This is the IP address of your Windows PC, where the MQTT server is running. You can find that with command prompt, and you type ipconfig. And this is the IPv4 address 192.168.164. So that will be different for you. You will need to check that with ipconfig. The IDE is connected to GPIO 2. The potentiometer is connected to GPIO 34. Here we enter the setup. Here we define the MQTT server port, which is 1883 by default for the Mosquitto server. And here we have a function to set up Wi-Fi. It will also show the status in the serial monitor of the Arduino IDE for debugging. And here you have the function handling the MQTT. Also, these messages are visible in the serial monitoring of the Arduino IDE for debugging. Now here you see the MQTT message topic that controls the IDE, ESP32 output. It must match the Node-Red MQTT out node. So let's check that. We start Node-Red, Node-Red. Node-Red is started. Also the broker is started. Now we open the browser, we type the IP address 192.168.1.64, the 1880 for Node-Red, enter. Now this is the switch. Let's have a look at this output here. ESP32 output. That is the same as here, ESP32 output. Now if the message content is true, we will switch on the LED. If the message content is false, we will switch off the LED. Now let's have a look at Node-Red again. The switch will send an on payload is true and the off payload is false. So that matches with the message content here. Then we have here a function to connect and reconnect to the MQTT. That's also a standard function. So here you see again ESP32 output. This is the topic we subscribe to, so that must match the switch MQTT output node of Node-Red. And here we go into the loop. This is the refresh rate. So we will send out the potentiometer value from the ESP32 every 2 seconds. Here we read the analog value of the potentiometer at potentiometer pin. The analog value is 12 bits, so it's 4096 maximum. I divided by 40 to get a value which is more or less 0 to 100. Here we transfer the temperature value to a temporary string. And here we publish the result to ESP32 temperature. That is the same as the MQTT in node of Node-Red. Let's have a look again. ESP32 temperature, that matches with this topic. Now let's upload this code and see how it works. The code has been uploaded. Now let's open Node-Red. Change here to the user interface by typing UI. Let's first try the switch. You can switch the LED on and off with the switch. Now let's test the analog input. So you see the gauge moves together with the analog value and the values are recorded in the chart. So the whole system works perfectly. Now let's add a second ESP32 client to the system. For the second ESP32, you need to change 3 things. First, you need to edit the MQTT message topic path in Node-Red. We will change it from ESP32 to ESP33. You can choose any name. Then you edit also the MQTT message topic path in the Arduino code to match Node-Red. And finally, you will need to change the MQTT client name in the Arduino code. We will change it from client to client2. This way, the MQTT broker knows it is another device. Let me show you how to make these changes. We first go to Node-Red. Here we are in Node-Red. Now we copy the temperature and gauge. So we have a second one, and we change this topic path to ESP33. Then we copy another switch and also the MQTT node. Let's call this switch 2. And also here we change the path to ESP33. And we deploy. Now let's open the dashboard, and you see there are 2 gauges and there are 2 switches. Now we go to the Arduino code. This is the Arduino code for the second ESP32 board. I updated the MQTT messages to match Node-Red. For this, I changed ESP32 to ESP33 in 3 places in the code. In line 61, where it checks for switch message true or false. In line 79, where it subscribes to the topic for the switch. And in line 104, where it sends the temperature value of the second ESP. Then I updated the MQTT client name from client to client2, so the MQTT broker knows it is another ESP32 board. The client name is used many times in the code. I changed all of them from client to client2. Now let's try it. Here you see the 2 ESP boards. The second board has an LDR connected to GPIO 34, so it can detect the light level. Switch 1, switch 2, so you can control the LEDs, and when it gets dark, the LDR will detect it. I hope you liked this video. If it was useful for you, please like and subscribe, and let me know your experience in the comments.